Hello, thank you all for being here. I'm very glad to share our paper, Robust Image Outpainting with Learnable Image Margins. This is a joint work with Cheng-Yo Tan, Chaoan Yang, Shangfu Chen, Mengling Wu, and Yucheng Frank Wang. So what is image outpainting? Image outpainting aims to synthesize image pixels with limited guidance of the surrounding regions of input images, while spatial and semantic practicality are simultaneously preserved. For example, to synthesize a complete head of a man, given only his left face, or to synthesize a full bird, given only its partial body without its head and tail. A range of applications in computer vision and image processing are closely related to image outpainting, such as view expansion and image panorama creation. Currently, most related works focus on fixed margins image outpainting. The input images are required to be located at a specific region, because the models could only outpaint images in fixed directions with fixed distances. Recently, a new method is proposed to overcome the above limitation. The new method could outpaint images with arbitrarily designated margins. However, although they allow input images to be located with different margins, they further require the image margins to be given as inputs. Unfortunately, such information might not be easily accessible in real-world applications. Therefore, our motivation is to alleviate or remove the limitation. We designed a method which does not require the filling margins to be given as inputs, while still allowing outpainting with arbitrary margins. Our proposed method could be depicted in this pipeline. We found that margins are learnable and predictable, so images are the only inputs in our pipeline. Our model first predicts the filling margins of the input image and then outpaint it according to its predicted margins. In this paper, we proposed a training framework to achieve our goal to outpaint images with learnable margins. We will detail the framework as follows. First, we proposed a margin prediction network, MPN, to leverage visual clues from input images and predict corresponding filling margins. We trained the MPN by minimizing a L1 distance margin regression loss to recover reasonable margins in a self-supervised manner. Our inference framework is similar to our pipeline. MPN first predicts the filling margins of input image, and then an encoder-decoder network outpaints the input image according to its predicted margins. To further improve the quality of the outpainted images, we introduced a teacher-student network in our training framework. The student network used for inference is regularized by an autoencoder teacher network, which is pre-trained to fully recover the ground truth image. The teacher-student network helps guide image outpainting with both image-level appearance recovery and feature-level consistency guarantees. We will detail the guarantees as follows. The first image consistency guarantee is a L1 image reconstruction loss. Since our generator is shared by both teacher and student networks, it is trained to exhibit capabilities in recovering and extrapolating photorealistic image outputs. Apart from pixel-wise supervision provided by reconstruction loss, we also adopt the contextual adversarial loss proposed by Wang et al. To make the outpainted images more realistic. More specifically, we consider a global discriminator and a local mask patch context discriminator with improved Vasistern distance. These allow our network to better capture both global and local semantic information. To encourage our student encoder to extract features with expanded visual information for outpainting, we also adapt feature consistency guarantees. We first pre-train an autoencoder teacher network to extract features from ground truth images for reconstruction. By enforcing the consistency between the outpainted features and the recovering features, we ensure the features extracted from our student encoder contain sufficient information for fair reconstruction, and thus is guided to include satisfactory content for image outpainting. In addition, we also adopt perceptual laws to the features extracted from outpainted images. Such enforcement would further ensure the outpainted images to be similar to ground truth images in perceptual aspects. We conduct our experiments on two datasets, SLAB AHQ and CUB. In our experiments, we show that our method is able to generate reasonable, realistic, and detailed outpainted images on both datasets. Note that our method does not require image filling margins to be known in advance, but the previous state-of-the-art method, SRN, requires margins as additional inputs. Moreover, to evaluate the robustness of our method, we arbitrarily crop partial images from different locations of the same ground truth image and predict margins from each of them and outpaint them accordingly. This experiment shows that our model is robust and is able to leverage visual clues from inputs to predict corresponding filling margins. We use quantitative evaluation to further show that our proposed model achieved comparable results without taking the filling margins as priors, and report improved performances when such information is given during inference. In our conclusion, we present a deep learning framework which outpaints input images in all four possible directions without the filling margins to be known in advance. We also introduce a margin prediction network that first predicts the filling margins of the input images, and incorporate a teacher-student-based network into our proposed framework, which guides our outpainting module to preserve image quality with both image and feature consistency enforced. This is the end of our presentation. Thank you for listening, and I hope you all enjoyed my talk about our work.